Okay, continuing our review. Number 7 says write a similarity statement for the similar quadrilaterals, then write an extended proportion relating the lengths of their sides. So what we can do to start with, we want to write a similarity statement. So we can name I'm going to go ahead and name the larger quadrilateral, which I'm going to start with A. So A, B, D, F is similar to, and what corresponds to A? Well, G does, so order is important. Then G to C, and then C, so we had A, B, G, C, and then B to D, so C, D is next, and then E. So that is the similarity statement. And then for the extended proportion, what we want to do is write a ratio of corresponding sides. So we can say AB, that's this length here, over GC. That's going to be equal to BD, this entire side, compared to this side, CD, equals, and then coming DF over DE, and then the last one, FA over GE. So there's the extended proportion. Number 8, find the value of each variable in the similar triangles. Well, it's telling us these triangles are similar, so we need to know sides are proportional. So what we want to do is we want to find that ratio. So we want to find corresponding sides that we know both of them. Well, we know the 10 and we know the 15. So our ratio is 10 to 15, which actually reduces to 5 goes into both of those, so 2/3. So our ratio is 2/3. So we can write 2/3 equals 8 over B. And then we can cross multiply. So 2B is equal to 24, which B then has to be 12. And then the other one, we still have the 2/3. And now we want to relate these two. So A and 6. So A over 6, again, we can cross multiply, and you get 3A equals 12. So A equals 4. So we found the variables. Number 9, name 3 postulates or theorems used to prove that two triangles are similar. I'm going to squeeze that in here. That's angle, angle, side, 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 angle, side. Number 10, true or false, a regular polygon is always similar to another regular polygon with the same number of sides. Well, in order for polygons to be similar, their angles have to be congruent, which that will be true. So that's the first part. And the sides will be proportional. Well, that will be true also because for each side, they're the same length, so it's going to be the same ratio to its corresponding side. So that's true. 11 and 12 say, if the triangles can be proved similar, write a similarity statement and name the postulate or theorem that justifies it. If not, explain why. Well, this first one, we see that two angles, so angle A corresponds to angle E, and B and D are both right angles, so these two are similar by angle, angle. And we can write triangle ABC is similar to triangle. And now the order is important. What corresponds to A? Well, that's E. So we start with E. And then we went A to B, so we went to the right angle next. Well, we need to go to the right angle next, which is D. And then our leftover is F. For number 12, we do see that these are congruent. So we have an angle congruent to an angle. So it's going to be either angle, angle, or side, angle, side. Well, there's no other angles, so we have to see if it's side, angle, side. Well, even though, so we have 8 over 20. 8 over 20. Is that equal to 10 over 25? Well, these both reduce. 4 goes into this 2 times and 5 times. 5 goes into this twice. 5 goes in this 5 times. So those are both 2/5. However, these are not in the order side, angle, side. This is more like a side, side, angle. So we cannot prove they're similar. And the reason would be it doesn't fit side, 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 angle, side, or angle, angle. Those are the 3 ways to prove they are similar. State whether the given lengths could be lengths of similar triangles. If so, state the similarity ratio. I'm going to zoom in a little bit here. So we want to make sure we compare shortest with shortest, middle with middle, and longest with longest. So over here, 8 is the shortest, so 8 to 4, which reduces to 2. Next is 9, and next largest over here is 5.5. Does that equal 2? It doesn't. It doesn't simplify to 2, and so they're not similar because the proportions, it's not proportional. Next one. Now notice looking at these sides are listed from shortest to longest, as are these. So we can just write 12 to 16, which reduces to 3 over 4. Now let's try the next one. That's 27 over 36. That's 27 over 36. 9 goes into both of those, 3 and 4. All right, so we're 2 for 2. Now we want to try the 36 and the 48. And what do you know? Those are, you can simplify by 12, 3 and 4. So they are similar because of side, side, side. What is the similarity ratio? Well, it's 3 to 4. We see it in all 3 of these. And then the next one said was 16. So a state park is building a boardwalk over a pond from A to B. So they're building this walkway here. The rangers placed a pole at C, measured AC and BC. All right, so they placed a pole here. AC and BC are 50 feet and 60 feet. Sighting along these lines, so they looked along this line, and they placed a point here at D, and looking along this line, they placed a point at E. How long is the planned boardwalk? Justify the reasoning behind the method of indirect measurement. So they're not actually measuring from here to here. Maybe there's alligators in this water or something. So can we find that length? Well, first of all, we can. These angles are congruent. These sides, so 10 over 50, 10 compared to 50 is 1/5. And then 12 compared to 60 is 1/5. So these triangles are similar by side, angle, side. Well, since they're similar, we know that sides will be proportional. So we know this 1/5, this ratio, has to equal 9 over x. So we can cross multiply and we get x is 45. So maybe not drawn to scale, but it does work out, 45 feet. So that's part 2. We'll continue some more questions in the next part.